Okay, in this example, what I'm going to do is show you how to get through this demand for golf clubs problem. This is explained completely in the book on page, roughly around page 50 and above, 48, 50, around in that area. So if you had read this, then you should be able to understand it, but I'm going to try to help you anyway. First thing you need to do is you've got to figure out exactly whether a linear function, a powered function, or an exponential function fits the data the best. So you can come up with an equation you can use to predict what demand will be at certain prices to judge which method is the most accurate as a sales forecasting method. Once you know which method is the most accurate, then what you can do is you can then create a profit model from it over here. But to start off with, the first thing we have to do is we have to figure out what the equation is of the linear relationship between this x variable and this y variable, what the power relationship equation is, and what the exponential relationship is. The easiest way to do that is with a scatter plot. You go like this. You go insert, you grab scatter, and then what you do is you would highlight, insert. Actually, what I do is I grab this first. Go to scatter plot and see what it's done here. It's actually, created a graph of along here is price, and along here is demand. I'm not going to label the axes. You can do that on your own. And then the next thing we want to do is we want to add a trend line to this. You got to select the data, right click, and then you go to add trend line right here. We're going to do this 3 times. The first time will be linear, the next time will be power, and the last one will be exponential. Let's do it linear now, and you want to put display equation on chart like that, and then you click on close, and then it gives you this equation. Y is the demand, X is the price. You plug the price into X, calculate the result of this equation, and that's your Y value, which is the demand. So you get 211.31 is the intercept, and 0.354x is the slope. This is like y is equal to mx plus b from your basic algebra. Okay? When you have that, then what you've got to do is make a prediction of what each one of these prices would be using this formula, of what the demand would be based on these prices using this formula. So you're going to go like this. You're going to go the slope, which is 0.35, make it absolute by pressing the F4 button, multiplied by the price, plus the intercept. And that should give you a value of 51.74. And I'm just going to quickly check that to make sure I have that right. Yes, I do. Okay, so now that I have that right, I can take that formula and then I can copy it down here. Oops, something's off. That should be absolute. So I'm going to try it again. Copy. Take this all the way down like that. And those are what you would predict your demand should be at each one of these price points right here. Okay? All these price. Plug them in the formula for X. The result is your prediction. Okay? So we got that done. The next thing we want to do is repeat this scatter plot again. Like this. And it's going to give us another one now. We want to select all of the data points, right click, add trend line. This time we want to go with a power equation, and we want to put the equation on the chart and click close. And that is what, and I'm just in the interest of, I'm going to put it right on top. This is the formula right there that we should be using. So now to see if it looks right. Yeah, that's it right there. I just wish we could see what that value is. Okay, I'm having trouble seeing exactly what that equation is, but the book tells us, okay, that, whoops, okay, I'm going to make this power again, display it on the chart. Okay, this is becoming a mess. Just delete all that, start over again. Okay, I'm going to go back to this original one, right click, add trend line, make it power, display the equation on the chart. Okay, well you can see it there, it's just messy. Start over again. You already knew how to get the linear one on. I'm going to put this power one on again. I'm going to go insert, scatter, these, right click, add trend line, make it power, and display the equation on the chart. Click on close. Okay, and then that's the equation. The exponent is negative 1.9082. 1.9082. And then the constant is 6 times 10 to the 6th, which is a really big number. Your textbook actually got it down to a number very close to that, 5871064. I'm not sure exactly, I think that's very close to 6123123 times 10 to the 6th, this number here, but somehow they got it a little more precise than what we're able to see on this chart here. Check your textbook on page 48, 49, 50 to see exactly how they got the exact number. I'm not going to get tied up with that right now. Okay, so now we have that, and what we can do is we can see this equation is this big number multiplied, this big number plus, no, this big number multiplied by the price raised to the exponent of negative 1.9082. So to arrive at that prediction, I would go this, and I'm going to press F4 on my keyboard in order to make this an absolute value, plus, not plus, multiplied by that raised to the power of this exponent. And that is the prediction based on a power function. And I am going to make sure that this is an absolute value so that when I copy it, it always goes back to that cell right there, so I don't get that error like I had last time. Let me put that all the way down. Okay, those are my predictions of what the demand should be based on the power function. Now I have to redo this chart another time. I'm going to get rid of it. And I'm going to highlight this. I'm going to go Insert, Scatter. And I'm going to select this data. I'm going to go Add Trend Line. But this time I'm going to make it exponential. And I'm going to display the equation on the chart. Close. And there it is. 46651E. Okay. So that means that the constant is 466.51. Okay, I'm getting that from here, right here. Okay, 4651 times e to the power of this number, which is negative 0.00491. Negative 0.00491. Okay. And what I have to do now is I have to come up with an equation that will allow me to predict what the demand will be under this situation. So what I'm going to be doing now is going equal sign B25. I'm going to make that an F4. Whoops. And that's going to be multiplied by and then I'm going to use a formula which gives me this constant called E. And if you don't understand it, I would just accept this to get through this at this point. You can look up what E means on your own at some point. And the exponent multiplied by this, F4, raised to the power of B4. Which is going to be this particular price. Now that is supposed to be the prediction under this scenario, but it doesn't look right to me. Now it's multiplied by B4, not to the power of B4. The reason I knew that is that the prediction should be somewhere within the range of the other predictions. We just want to know which one is the most accurate. Okay, so you see this formula I've got it up here? So it's using this equation down here in order to arrive at what the predicted price, demand would be at these different price levels. Okay, so now I have all of these predictions for every single one of the prices that we had over here, all the way from 450 down to 390. Although this isn't what they do in the book, just so you can see it. What we're saying is at this price, the linear equation says we should sell 51.74 units, the power says we should sell 50.8, and the exponential says we should sell 51.2 based on this particular price. The question is, which one of these predictions is the most accurate across this full data set right here? Well, to do that, you need to calculate the absolute percentage error. And I think that this is enough for this particular video. So what I'm going to do is I'm going to save this, and then I'm going to start another video that picks up right at this point so that you can kind of digest this so much. If it's gone by too fast, then just rewind it. But I'm going to post this to YouTube right now so that you can see what it is.